Hello everyone. We're now on part 2. We're going to go on to splitting pattern. When we look at splitting patterns, we're going to be using the n+1 rule. It all involves, if you're looking at one region, say this CH3, you have these 3 hydrogens that are all identical, and you can see on this this ethanol spectrum, this H-NMR readout, all these have a bunch of points on them, except for the OH, and we'll see why in a second. This one has 3, this one has 4, and this one has 1. And you can tell these by what they're adjacent to. So this CH3, you can see, is adjacent to a carbon with 2 hydrogens. So these 2 hydrogens means it's n+1. So 2 plus 1 equals 3. So if we look at the CH3 peak, which is here, we can see it is a triplet. It's 1, 2, 3 because it is adjacent to 1, 2, plus 1, 3, right? So if we go to the OH, it's not adjacent to anything because it's complicated, but you can just think of it as the O blocking it. It actually has to do with a solvent taking off the hydrogen, but I'm not knowledgeable enough to explain that, and you don't need to be for the IB test. But just know that there's 1, so it's there's nothing adjacent to it. So 0 plus 1 is 1. It's a singlet. And then if you look at the CH2, it's adjacent to a CH3. There's 3 hydrogens. N plus 1, 3 plus 1 is a 4, and it's a quartet. So that it's pretty easy, the splitting pattern. You just have to remember N plus 1. So now we're going to be looking at some practice problems. You have here 2 molecules that you need to determine the number of signals and the ratio of areas. Remember, you do this by the groups of hydrogens that are chemically identical, right? They're the same. And the ratio of areas is done by how you compare the different groups. So if you have how many signals, how many hydrogens are in each of those signals. And if it's like 2 and then 3, then it'd be 2 to 3, right? So I would pause here and think about that, and I would seriously try it because this isn't something you can just watch and then know. You have to practice a little bit because it's a little tricky. And then here, the structure of morphine, dimorphine, and codeine are given in section 37 in the data booklet. Methadone is used to treat heroin addiction. H-NMR spectroscopy can be used to study its structure. Determine the number of different hydrogen environments in the molecule, ignoring the benzene rings. So you ignore these. So how many signals am I going to get on my H-NMR? Then predict the chemical shift and splitting pattern for the hydrogens on the carbon atom circled. So you're going to have to look at your data booklet and see where this would shift on your H-NMR. You probably don't have a data booklet with you, but so I would focus on these 2 and finding how many signals you'd get on your H-NMR for this molecule. And I'd pause here, and then in a second I'll reveal the answers. All right, hopefully you're done. We can remove this. For compound A, you're going to get 5 signals because you can see 1 here, 2 here, 3 here, 4 here. There's 2 CH3s. Yep, and then another here. So 1, 2, 3, 4, 5. Right? And then the area is 6 here because there's 3 hydrogen, another 3 hydrogen, grouped together 6 to 1 to 1 to 1 to 1. When you look at B, 4 signals because there's 1 here, 2 here, 3 here, and 4 here. And the ratio is 6 right here to 2 is here, and 1 to 1. And then I'll only got 25 seconds left, so I'll remove this here. There's going to be 6 regions, 1 here, 2 here, 3 here, 4 here, and 5 here, and then 6 right there. And then you can see the chemical shift in the splitting pattern is a quartet. Thank you for watching. Hopefully you understand. If you have any questions, contact me.